Well, hello and welcome. It is time once again to try to fix something. And today on the workbench we have another PS5 that is a bit under the weather. Not just being very, very dirty, if you can look down in there and see, but she's not working, I believe. Let me see what exactly it is doing. Power is connected. Let me just show you what we're starting with here. Beep, and no lights. She will beep every couple of seconds there, every second maybe. So she beeps a lot, but that's about it. Let's get some covers off and see if she's been opened up before. And the side plate is off. And yes, it does my heart good to see that security tape in place. Excellent. May have to blow it out a little bit, or a lot. But yeah, let's get a little further into it. At least it has not been worked on before. That's always good. Well, we are inside of the workbench, ready to take a look at this PS5 motherboard, which is an EDM20. Yeah, EDM20. That will just beep. Let's just check the current draw of this thing. It's a good place to start. Make sure the polarity is right. Let's see. What does she draw? 10 and 33, and then back down to 10. Try that again. 10. Yeah, and then 30 milliamps, and then right back down to 10, really quick like. That's a whole lot of nothing going on there. So do we have a short somewhere? It's a good possibility. Where do we start? Well, I don't believe we have a 5-volt short, because we wouldn't be doing much of anything if we had a 5-volt short. Wouldn't be beeping, wouldn't be doing anything. Well, it beeps when the HDMI encoder is shorted. Let me get that in the picture. Yeah. Let's see. I'm in continuity mode. I'm going to get on some of these small capacitors here to the bottom right of the HDMI encoder. There's 2 of them there on 2 different rails. No, not shorted. What about around this? This is the dialogue chip that makes the standby voltage. Like this should be 3. This is the 3.3 volt rail. 1.15. There's various other rails around it. I'm just checking on some of these bypass capacitors around it there. Not seeing anything shorted though. This is the back of the dialogue, or it could be a Rich Tech chip that makes the voltages for the SSD controller. Let's see, they have a ground also. What do we have? Here's the fuse, F7502. Oh, we have a short. A rather dead short to ground. So I'm assuming this fuse is opened up. Yeah. F7502 has opened. So we have a short on our SSD power supply. Yep. That's ground. And this should be the 5-volt rail going in. Very, very close to ground. So let's see. There are several bypass capacitors, that could be shorted. Here's the chip. I don't know whether it is. Have to clean it off to be able to see if it's the dialogue or the Rich Tech chip. They do the same thing. So we could remove the chip and see if the short goes away, or we could just inject a volt or 2 where the 5 volts would go in right here on this fuse. We could do that and see what gets hot. Let me check to make sure we don't have a short coming out of the chip, like on these inductors that make 1.2, 2.5, 0.8 volts. No. 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 And forgive me, I don't remember which ones are which. Which one's 2.5 and 1.2, but if you check on each one of these inductors around here, you'll hit them all, and they are not shorted. So the output's not shorted. The output of this IC is not shorted. The input is shorted, which sounds like a capacitor. I haven't seen. Well, I take it back. I have seen one of these things fail before. So it's not out of the realm of possibility. But the way these ceramic capacitors are on these PS5 motherboards, pretty good chance. So let me get set up. Can I inject on this side? I guess this is it. Yeah, there's where 5 volts goes in right there. Probably also on the top. Let's see. Like right up, that's 2 ohms. Right there. So I can inject on this side. There's more components on this side. There are some capacitors on the other side, but there's more on this side, I think. Well, maybe there's only like 2 on the actual input. Okay, let me get set up to inject. Let's just see if it shows up under the thermal cam. I bet it does. All right, well, the thermal cam is set up, I believe. I am set to inject 1 volt at 1 amp, and we are looking at the side of the board where the fuse is, the APU side. So the dialog chip is on the opposite side. We can flip it if we need to. So let me go ahead and enable this supply and see what happens. 1 volt at 1 amp. Oh, I see something slightly warm there. Slightly. Is that from the other side of the board? Let me turn it off. See if I can flip this over without knocking my leads loose. All right, now we're looking at the side of the board with the dialog chip. 1 volt. There we go. Something's glowing. Something is glowing. Where'd it go? No, it's just a reflection. Right, here's the dialog chip. No, that was just a reflection I saw. There's nothing warm on this side of the board. The chip is right there. So we're totally cold. Let me turn it off. So was it on where I started? It just looked like the heat was a little bit diffused. Let's try that again though. It looks like there's heat right where I'm injecting. Exactly where I'm injecting. You can see that the wire attached right there. Okay. Let me increase the current. We're drawing 1 amp of current. We're at 0.15 volts and 1 amp of current. I'm going to ease the current up. There's 1.4 amps. Is it? I actually tacked my wire to the end of the fuse, and I'm wondering if it is that. I'm sorry, I tacked my wire to the end of a capacitor, a large ceramic capacitor. And I'm just wondering if that's where the short is. That's the only heat spot I'm seeing is exactly where I've attached the wire. What are the chances? Okay. Let's look at it on the microscope maybe. All right, you can see exactly where I attached that wire. Let me try to put a little alcohol on there, on that capacitor. Let me turn the supply back on. Put a little alcohol on there. It's shiny from flux right now. Turn on the power. No. I mean, it's not getting hot like I would think it would if it was a dead short. So is it the chip? That capacitor is evaporating. It is evaporating there, that and above. but it's not doing it very quickly. We're supplying 1.4 amps of current, 0.2 of a volt. Okay, let me turn this off. Let's raise this current up to 2 amps. And she is drawing 2 amps. Is it that capacitor? I'm not sure. I mean, it's evaporating, but I would expect it's dissipating 0.6 of a watt. Okay. I really thought that this would stand out better than it has. Let's look at the other side of the board. Let's look at the chip itself. It is the dialogue chip. I'm going to coat it with some alcohol. Apply a couple of amps of current. And I'm going to guess my lead came loose. Yep. Try that again. Inject 1 volt at 2 amps. Just not seeing anything really jumping out at me. It's disappointing. Wait a second. What about this little capacitor? These are going to be on the 5-volt rail. Right now the current is off. It's evaporating even with the current off, so yeah. I'm trying to get a lot of alcohol on it and turn it on. Because they're all evaporating pretty darn quick. Drawing 2 amps of current. I think I'm going to remove that dialogue chip and just see what happens. That'll, you know, nothing is jumping out, so we got to go somewhere. I'll just remove that chip and see if it changes anything. Alright, so our DA9081 has been removed. Has our short been relieved? Let's see. Right, this one. No! I've turned it up to 3 amps, looks like. Okay. So we can look under the microscope. So it's not the chip. It is not the DA9081. So it just about has to be a capacitor under there somewhere. Let me get some alcohol. Anything here? Nothing jumps out at you. Oh, that capacitor up there did dry off first. You can see the alcohol move when I apply the current. Kind of neat. See it move? Is it that one underneath the wire? Ah, yes. The one hiding under the wire. Okay. That's why I didn't see that one earlier. It was hidden. All right. Let's see if we can remove that one. Let's just see. Move that wire out of the way. What if I can remove it with these hot tweezers? Haven't used these things in a while. And the cable is wrapped around everything. Okay. And somehow it's still wrapped around everything. Okay. See if we can remove it. It's a rather large component for these rather small tweezers. Ah, I did finally get it. Okay. All right. Is our short now eliminated? Yes, yes it is. 1 volt being applied, 0 amps being pulled, 0 milliamps being pulled. All right, so we found our short. Finally. Let me get that back in focus. All right. I don't know what value these capacitors are. I'll just pull one from a donor. Let me just see here. Let's go ahead and unhook this. I don't think we're going to need this wire anymore. Let's hope not. This is an EDM20. Although I think an EDM10 would have the same capacitor there. Here's an EDM10. Yep. Let's just see. Yep, that one right there. I think I'll use hot air. I should have added some leaded solder to the end of this thing. They don't like to let go. And I usually do this to encourage them to let go. Dilute that lead-free solder a little. Let's see what the value of this one is. See if I can measure it. Although it's a little hot right now. And where did it go? And it's gone. Oh, and it really traveled. It didn't leave the desk, but it did travel pretty good. May have to clean the flux off of it to get a good reading. .22 microfarad. 22 microfarad. Alright, now we need to reinstall that DA9081. Clean this up a little. Let me just tin this a little, just for the heck of it. right. Well, we replaced a 22 microfarad capacitor that had shorted, which is somewhere, there it is over there if you can see it. Focus. There we go. Well, kind of. It's tiny. So I reinstalled that same DA9081, and we need to see if our initialization current looks somewhat normal now. Polarity is correct. Let's see, am I on the right? Yeah, these are my wires I was injecting with here. That's channel number 2. We're going to use channel number 1. 12 volts and half an amp. What does she do? No. Still not starting up. Do we have something else bad? Looks that way. Okay. Let me get set up. We can check what's going on around that DA9081. Oh, I just realized what's going on around that DA9081. Did you? Remember this guy? F7502? Yeah, I forgot to change him. Okay, let's do that. Okay, now that our F7502 has been replaced, what will she do? What will she do now? Hopefully more than she did just a moment ago. Okay, polarity is correct. How much current does she draw? There we go, 300 milliamps, and come back down. That looks healthy. All right, so yeah, I think we're good now. One shorted cap and one open fuse later. Will it focus? Kinda, sorta, yep. 122 microfarad capacitor and one 5 amp fuse. Because as far as I found, every fuse on a PS5 is either a 5 amp or a 2.5 amp. One or the other. Let's get this back out there in the chassis and see what it does now. Well, here we are back out in the garage, ready to test out this PS5. See if we've done any good. Got my fan connected. I have not bothered to clean the fan yet, as you can see. Let's just see if she will turn on. Power is in there. Let's see. Now we have a blue light. That's good. Fan is spinning. That's better. Do we get a signal on the monitor, though? Not yet. Not yet. I did not look at that HDMI port. Hope it's good. White light. And now we're doing a storage check. Excellent. All right. I think we're going to be all right. I've got a little more cleanup to do on this. Notably that fan. I'll put it back together. We'll let it run, give it a little test out, and I'll let you know how it goes. How's that sound? Come on. There we go. We're starting up. Splash screen? Oh, no, just the warning. Okay. All right, let me do a little more cleanup, and we'll finish this up. All right, well, this PS5 is fully reassembled. I've cleaned it up a good bit, and she is installing a game, and everything is working just fine. So one little 22 microfarad capacitor took it down, and that happens a lot, unfortunately. But she's going to be all better, I think, now. Working fine. So if you liked that one, thought it was somewhat interesting, educational, entertaining, any of the above, if you did, please give me a thumbs up. And I will see you in that very next repair. So long for now.